I think that looks like a 7, but it should be a 9. Anyway, hi there, everybody. My name is Michael Lay, and today I'll be talking about feedback loops and the female reproductive system, specifically the non-gravid female reproductive system, non-gravid meaning not pregnant. So first, I'll take you guys through a PowerPoint to discuss these exact mechanisms, and then I will relate this back to a case study that I found online. All right, now let's get started. So, if you've seen any of my previous presentations, you'll find that I tend to explain things by answering the five W's. So the five W's, of course, are who, what, when, where, why. My 8-year-old nephew always asks me these questions. He's always like, Uncle Michael, why? Uncle Michael, who, where, like, et cetera, et cetera. So at least when I learn new material, I pretend that I am like my nephew, like an 8-year-old. So as I go through this presentation, I'll answer the questions of who, what, when, where, why, and how. So let's talk about the what and the where. Um, so these are multiple images of female reproductive anatomy. Obviously, men don't have these exact mechanisms or organs, but what makes women unique is, of course, their reproductive organs and their homeostatic regulation of these organs with specific hormones. Now, right here is the uterus, and then it extends out to the ovaries, these little egg-like structures here. And well, they're egg-like, but they actually produce eggs. Now, and then these eggs, of course, leave the uterus and then out through the vagina eventually. And this is in the case of, once again, non-pregnant women. This is the structure of the uterus right here. As you can see, there's the cavity. This is just a little cross section of this area. There's my cursor. And then over on this side, this is the follicle, or like, sorry, the ovary, where the ovum or the egg develops into a primary follicle and a secondary follicle. It's usually expelled, and then the corpus luteum is a structure that remains. So once again, the very important uh, organs I'd like to point out, of course, are the ovaries, the uterus, and the eggs. So now let's talk about hormones. So sticking to our theme of answering the five W's, hormones will help us answer the who question. So I like to think of hormones as the key players in the female reproductive system here. So hormones are released from different organs. As you can see, I've highlighted these or bolded them. There's the hypothalamus, the anterior pituitary gland, the adrenal glands, reproductive glands, and ovarian follicles, of course, some of which I mentioned on the previous slide. Now, these hormones, they respond to stimuli, and whether that be a presence or even an absence of something in our blood. And they also have the effectors, which are, of course, these organs that I've highlighted. So out of the hypothalamus comes GnRH and CRH, corticotropin releasing hormone. The anterior pituitary has or releases luteinizing hormone and follicle stimulating hormone, as well as adrenocorticotropic hormone. And again, um, these are primarily the hormones involved in the specific mechanism I'm going to talk about. Adrenal glands release androgens, reproductive glands release LH and FSH, or at least they respond to them and actually produce them as well. And then finally, ovarian follicles produce progesterone and inhibin. Now, let's talk about homeostasis, or in this case, the tendency to resist change. Now, homeo means same, stasis means period of equilibrium. So our body uses hormones to help us maintain a state of equilibrium or balance at all times. And it does this using feedback loops. So here's an example of a feedback loop on the right-hand side, for example, that's very common in people. Now, I like to think about feedback loops as a repeating interaction or streamline of stimuli and effectors. So, in other words, there's always something affecting another thing, and so on. So, this can or cannot eventually have a stop. And that's how we determine whether a feedback loop is positive or negative. Now, negative feedback. Negative feedback involves one of the stimuli, well, feeding back and affecting one of the upstream regulators or effectors. So this can be done by either binding to a receptor and then inhibiting some of the upstream hormones from becoming released, or alternatively, the effector organ would be able to sense a lack of stimuli. And both of these things actually happen in the case of the female reproductive system. And I'll talk about that on the next slide. And now another example of homeostasis or the maintenance of it is, when someone senses that they're thirsty, like me, for example, I'm about to get my sippy cup right here and drink some water, helping me retain that fluid balance within my body. I need another sip, actually, pardon me. All right, sorry about that. Now, let's all put this together, right? So we've learned about the female reproductive organs, we've identified the hormones involved, and we have also discussed how they function to regulate homeostasis. Now, let's look at this figure right here. So let's start actually with what's happening right here at this peak. So you might notice that FSH and LH are involved, and right about here, during day 14 of the menstrual cycle, is ovulation. And so, as you can see, LH and FSH stimulate the release of the egg from the secondary follicle. And here, right around this time, you'll notice that levels of estrogen and inhibin are also increasing, but also very importantly, right when this egg is released, there's development of the corpus luteum. And now the corpus luteum secretes progesterone. And progesterone, uh, uh, oh, it also secretes inhibin, pardon me. So progesterone and inhibin actually have, well, inhibiting results on FSH and LH. So you might notice that as estrogen inhibin increase, FSH and LH production decrease. So this is an example of one of those negative feedback loops I talked about earlier. So inhibin affects FSH and LH release by acting on the the anterior pituitary, which then inhibits the release of LH and FSH. And progesterone actually has a different negative feedback mechanism that I also mentioned in the previous slide, where I mentioned that an effector organ might actually sense lack of something. So in this case, progesterone is actually very important in the development of the uterine wall or the uterine lining. As you can see here, as there is more progesterone, there is more uterine lining. And when this progesterone begins to decrease, as you can see, there's still progesterone, so the uterine lining will still develop, but just less rapidly. But anyway, as progesterone decreases over time, you will notice that estrogen and inhibin actually begin increasing as well. Now, the decrease of progesterone leads back to the first phase of the menstrual cycle, and this is the menses. This is when deterioration of the uterine wall occurs, and this, of course, is when women begin bleeding. Then, of course, there's a proliferative phase once bleeding stops, and then we return back to ovulation or the release of the egg here. All right. So just to recap everything, we've discussed the homeostatic mechanisms, the negative feedback loops involved in the non-pregnant female reproductive system. We've identified which organs are involved, which hormones are involved, and how they all function together. So that wraps up this part of my presentation. Now I'm going to move on to a case study. So I adapted this case study, or I took it from a really cool article from the New England Journal of Medicine. Now let's read it. A 31-year-old woman with a history of primary amenorrhea, which means lack of menstruation, And infertility was seen in the fertility center to discuss family planning options. The patient reported that when she was 16 years of age, she had been evaluated for primary amenorrhea and had received a diagnosis of congenital absence of the uterus and ovaries. When she was approximately 12 years of age, um, adrenarche and thelarche had occurred in association with a linear growth spurt. The patient had never had menstrual melamina or any headaches, vision problems, galactorrhea, vasomotor symptoms, or reduction in exercise tolerance. Now here's some laboratory data. So you'll recognize some of the hormones from the presentation I just did, and we'll answer some questions now. So let's exit this PowerPoint and begin answering these questions on our worksheet. Okay, so what reproductive organs were missing? As it mentioned in the article, she has congenital absence of the uterus and the ovaries. So uterus and ovaries, which hormone levels were low compared to baseline, and we'll find that. Okay, so we'll look here and we'll notice that FSH, LH, and prolactin were low. However, uh, concentrations of HCG, estradiol, and progesterone were actually normal. So remember that. These are androgen hormones, estrogen and progesterone. Now, what is this disease called? Um, this is actually an example of Mullerian, I'll type this one out, Mullerian aplasia, which is a hyperandrogynous condition. And is this disease hereditary? Um, yes, actually, it's inherited in an autosomal dominant pattern. Girls obviously can't inherit it from their mothers because women with this disorder are unlikely or can't have children, as seen in this case study. It's autosomal dominant, and actually, it's a result of a mutation in the WNT4 gene. So, WNT4 gene. And of course, which structures are altered? That'd be all of them. So you'll notice again, no uterus or ovaries, and disruption in adrenal and endocrine gland function. Okay, and that pretty much covers everything. I've talked about, I went through a PowerPoint discussing female reproductive anatomy and hormonal regulation, and then we just answered a really interesting case study about it. So thanks again, everybody, for joining me, and I hope everyone has a fantastic day. Bye bye now.